More than half the world's plant and animal species live in swamps and jungles. It's a vertical landscape that pushes the very limits of animal engineering. And when animals so brilliantly equipped come into contact, some of nature's most remarkable moments unfold. Snakes take flight. Tongues shoot with blinding speed. Feet walk on water. Crocs turn into toothy torpedoes. And finally, the ultimate moment, a tiger's unsurpassed strength and power. These are moments of wonder. Incredible, ingenious, and entirely real. Often they're too fast, too small, or too hidden to be understood. But if we can capture them, what it takes to survive in the jungle can finally be revealed. In the tropical rainforests of Central America, blue morpho butterflies often stay hidden in the shadows of the dark understory. Occasionally, they'll venture into sunny clearings to forage on food dropped from the canopy above. But in the jungle, danger lies in wait. A hungry lizard has caught sight of the morpho's shiny wings. And the basilisk lizard is uniquely equipped with the most wondrous means for capturing its game. The lizard's water walking seems to override the very laws of physics. A moment so surprising. To understand it, we need to unpack the critical steps that get this predator to its prey. It all starts with the morpho's wing shimmer. And it's with these wings that the blue morpho tries to mount a defense. First and foremost, they can escape by flying. But they can also stage a diversion, using a flash of their iridescent wings to startle a predator. In fact, their wings aren't really blue. The flash is a light trick, overlapping scales with tiny ridges that only reflect the color blue. What's more, when the morpho emerges from its cocoon, it's covered in markings resembling eyes. Eye spots can make a butterfly appear larger. As long as the morpho is flying, the lizard is no threat. But food at the water's edge tempts the morpho. Surrounded by water, it should be safe for it to stop and eat. With the pond in the way, most lizards wouldn't stand a chance. But this is no ordinary lizard. For years, cinematographers tried to capture its steps with varying success. Witnessed at normal speeds, their fleet-footed water dance leaves nothing but questions in its wake. But slowing the action lets us see why this animal's become so famous as the Jesus lizard. It starts with the unique biomechanics within the lizard's legs and feet. Every time it slaps its wide-webbed foot on the water, it turns something that's fluid into firm footing. When their foot plunges down, it creates a pocket of air and force for support that keeps the lizard from sinking. And there's another trick at work here, the sideways force. Each lizard leg is pushing slightly outward. So, like riding a bike, each tilt to one side is corrected and counterbalanced. Of course, if you stop pedaling, you'll fall over. If the lizard stops running, it will sink into the water and have to swim the rest of the way. At the moment of the basilisk's approach, a final flashing of the morpho's wings. But it's not enough. The lizard gets its meal. Just one small act of survival, but a hint of the internal engineering that allows species to tackle an environment and thrive. Whereas much of the action on the shadowy forest floor goes unseen, up in the trees, the jungle's miraculous movement is a thing to behold. 50% of the world's animal species live up here, and it's led to some remarkable motion specialists. Ones for whom our rules for getting from here to there just don't apply. The long-limbed spider monkey is perfectly suited for a life in the trees. At 150 feet up, this is a risky high-wire act, requiring a body that's been customized, turning a monkey into an Olympian. In the rainforests of the New World, spider monkeys are a force to be reckoned with. They turn a network of branches and vines into a jungle highway. It's called brachiating. Agile primates like the spider monkey are capable of moving arm over arm through the jungle, even hurling themselves over 30 feet between trees. What's normally a blur is in fact a whole series of moments. Moments we can now see. Each a calibration of strength and timing between body and branch. The arms and legs of monkeys are scaled differently than ours. Forelimbs and hind limbs are equally long. A dexterous tail works like a fifth hand. It's even tipped with fingerprint-like grooves. Shoulder joints are rounded to allow maximum rotation. Freewheeling wrists and hook-like hands give them an acrobatic advantage for swinging. All this internal hardware paves the way for a very high-performance ride. Like most primates, they've reduced their powers to detect smell, to increase stereoscopic vision, essential for navigating the branchscape and finding their way to scattered sources of food. Spider monkeys are known to cover more than a mile in a day foraging for fruit. Their astonishing powers of locomotion help them deal with the challenges of this high-rise habitat. Not every creature living in the canopy has taken up the Tarzan Act. But even if they don't climb, or leap, or even walk very fast, they've got some surprising ways to obtain life's essentials. The forests of tropical Madagascar are home to about half the world's chameleon species, including the vibrantly colored panther. With almost everything it does, this chameleon is the personification of slow. Their tongue-like feet, working like pincers, and grasping prehensile tails keep them steady as they amble through the trees. They're in no hurry because nature has armed them in a different way to compete for canopy insects. And when one of them gets in range, Mr. Slow turns out to have an astonishing moment of speed. And its fast, telescoping tongue is matched by a quick, color-changing skin. Contrary to popular belief, chameleons don't change colors to camouflage their presence against the surroundings. It has more to do with communication between very solitary creatures. A rare moment of contact and a flash of emotion. Coloring reflects their mood when sparring with other males. Or when they're attracting the attention of females adorned in a blander exterior. The mechanics of this color change take place just below their transparent outer skin. Stretchable pigment cells, called chromatophores, are ringed with muscle fibers. When the fibers contract, they pull on the pigment cells, quickly spreading their color. The upper layer handles red and yellow tints. Below, another layer of cells reflects blue light. While the chameleon's skin show is impressive, it's their tongue's capacity to snatch a meal from a distance that really defines the moment. The unusual attack begins with the chameleon's eyes, the most distinctive of any reptile. Each eye can rotate and focus separately. With but a pinhole in the center, they have a full 360-degree view to find prey. The slow-moving chameleon never chases the quarry, only edges towards it. He moves his head, bit by bit. Now, the eyes are locked in sync to judge the distance. Then, the tongue takes over. About 20 milliseconds. That's all it takes. But with high-speed cameras, we can observe the action as it catapults over 1,600 feet per second. How it works is another case of animal ingenuity. The tongue is sheathed on the tip of a bone that helps support it. A tightly coiled spring of collagen and accelerator muscles create a biological catapult that propels the tongue tip as a bow shoots an arrow.